Elaine Czech. I'm from the University of Bristol, and I called my talk Data Will Bring Us Together, and this is related to my postdoc, which is thinking about how we can map the data life cycle to co-design AI with multiple stakeholders. So this work is being done with Ashton O'Kane and for Now, one of these will move it. There we go. Manually. So I am a human-computer interaction researcher, which is why all of my slides will probably look very different from everyone else's slides. But what does that mean? My background is awesome. There'll be lots of bright colors. But that means that essentially I look at how people use systems. And I'm moving more into human AI interactions, thinking about how people use algorithms. And the project I'm on is called Port Project. And it is a UKRI-funded project, and it incorporates computer vision, so thinking about pose estimation, facial recognition, depth sensing, really to get sort of skills points. It also is combined with a wearable, so I have a little wearable there. And that is to kind of this EMU sensor and tracking mobility and temperature. Yes, tracking mobility. And then there's a temperature and pressure sensor, which is all tracking stairs. And then there's going to be collection of, and all of this data that's going to be collected, so like the video data and the wearable data and potentially personal data, is to help with monitoring or passive monitoring of Parkinson's progression. And the idea is that there would be this monitoring happening in people's homes, and then that data could be used to help understand if disease-modifying therapies are working in clinical trial. And specifically, my role in this project is to look at end users and say, well, how do they feel about this system being implemented in their homes, and particularly because it is in their homes, which is a sensitive and intimate setting, and then we're also collecting health data, which is also another privacy issue. This is where I come in, is to be like, well, how would you actually feel about this, and how would we do it in a way that you would be comfortable with it? Now, it's very complicated because security concerns with end users can be hard to parse out. A lot of the times, most of the general public doesn't understand what an algorithm is or how an algorithm is impacting their lives. So there's been work by Lewis et al. Looking specifically at algorithms in healthcare and in pathology. And in the UK, there was a low understanding that these algorithms were already being applied in pathology. And then there was also a low sort of level of trust that the information, or it's even de-identified information that's being used to train these models, is not going to be misused in the future. But one positive that they did find is that as people were able to understand better how the AI system worked and was working with to understand and sort of classify the pathology data, they were able to have more trust in the system. And one way we can build trust in the system is by actually including end users in the design of algorithms. One thing that Verisech et al. Found is that by including end users, they start to build an interpersonal relationships with the engineers who are building the systems, and that actually helps them to build trust in the final product. So they build trust with you, the person building the algorithm, and that then makes them go, oh, actually, I trust the system. But, there's always a but, that is complicated because oftentimes when we try to get end users involved in algorithmic design, we think that we need to upskill them a lot, which means that we think that, oh, we need to train them how to read all of the mathematical equations, and we need to get them to understand why, significantly grasp what data is doing in machine learning and knowing basically every step in order to get them to understand how to build an algorithm and what their role is in an algorithm. Now, as I've said before, building understanding in AI can help to build trust, but the problem is that even if you have this understanding of AI, the problem is that, or even if end users, I should say, have this understanding of AI, it doesn't mean that they know how to express their concerns around safety and privacy very well. So this has been an issue because they don't necessarily think oh, okay, yeah, I understand, you put my data in, it's being sort of manipulated in this way. but then they don't necessarily think about, well, where specifically are the security concerns going to come up. So Pudig and Singh, they found that actually if you root their sort of understanding in the real world and get them to think about the needs and considerations in the context, that can help them to really pinpoint where the concerns would be and where you need to maybe risk mitigate. Now, I've thrown a lot at you, and if you followed along, basically, if I am keeping in line with what other researchers have done, my role as an HCI person would be to then bring in users into the room, teach them how to make an algorithm, and then also root it in the real world, which can be very complicated. But I think instead of upskilling in the way that we have been doing, there's another way that we can do it. So I was thinking, well, what if we co-design and co-develop the algorithm around what stakeholders, so engineers and end users, would have in common? And that is where the title of my talk comes in, data. So data is something that end users are inputting and they're using, while as also engineers are using and manipulating, so it brings this all together. Now in human-computer interaction, there's, well, and in general, we all understand that data is not really a concrete thing. It's an abstract concept, and making it concrete can be really helpful. So there's this idea and this whole history and field around data physicalization. And basically, when we make our data concrete, it helps us helps with supporting cognition, communication, learning, problem solving, and decision making. So when it comes to talking about one's data. Now, of the work that exists already in data physicalization, there's been some done with how to explain AI, but none to think about how we could develop AI. So with this research, I wanted to answer the question, well, how can we get people to care about data and in turn develop a more secure algorithmic system? Now, my project has been creating some design workshops and working with all of the different stakeholders that are impacted and involved in the TOR system. So again, TOR system being that passive monitoring system for Parkinson's monitoring. And so this has been getting people from all of the different facets of the TORS project into the same room and getting them to talk about data. So this has been wearable engineers, video sensing, data fusion, integration engineers, along with people with Parkinson's and clinicians. And as I was trying to think about how to design this workshop to get people to talk about data and how it would actually impact algorithmic development, I came across this concept of the data value chain. So essentially this chain created by Lin et al. Is that idea that as data moves along the chain, value is then created and people are able to put to use the valuable information. However, the reality is more like Ettar, Frost, and Witter's model, which is that value is actually added at each point of the development. So at each point, they have an error going in and an error going out. So at each point, a person or stakeholder is involved in putting something into the algorithm and something is coming out. So there's value going in and value coming out, and then that all sort of loops together. So to give a nice, beautiful illustration of that, and this illustration even scares me, but it's kind of, this is an example of thinking of cardiovascular disease and in thinking of it in sort of that model. So you have the data provider, which would be sort of the heart health. This is where you have sort of the end user is putting in this data, their heart information through Bluetooth wearable, and then sort of that data is then going out into sort of to be engineered to be used to develop the model. The model is also having some value input from the clinicians, with prognostic and diagnostic information about heart. Then you have a sort of an output where you might build an app, and that also then means someone else is being involved, adding value to this data and changing it and manipulating it, and then eventually it goes to the end user. In this example, it is the people with a heart condition, and they might use that to understand their heart better. So hopefully that all makes sense. Basically, the short of it is value comes in at different points by various stakeholders, and value goes out to various stakeholders, and we're all very connected through the data. Yeah. And so I then designed the workshops to be built around this sort of idea. So there was 4 different workshops to move all of the stakeholders through the value chain. So the first one was thinking more generally about movement,
because Parkinson's is a cognitive disorder that affects people's movement primarily. It can also affect cognition, but we're focusing mostly on movement. So thinking about general movement throughout the day, and then general movement throughout the home. And then thinking about how we would deal with that data, so thinking about missing data and data mitigation, and thinking about how we would think about the storage of the data and what privacy concerns might come up with the data. Then breaking that down even further by thinking of the timelines of, well, when is data being gathered at what times, and when are people specifically manipulating it? So like thinking about the wearable team, they're going to be taking certain EMU data and at certain times and taking it into the cloud, or if they're doing a post hoc analysis, they're going to have it collected at some point, but it's going to be stored for some amount of time, and getting end users to be like, well, are you okay with it, your data being just stored on a server for X amount of time, not being touched? And then finally, our last workshop is going to talk about information delivery and the user. So thinking about what are those actual outputs that are going to happen, so that specifically the data fusion team knows what sort of value they need to be creating with the data. Now we have some preliminary findings. This work is ongoing, so I'm hoping that in my sort of exit interviews with all of the members, we'll get more of an understanding of how they will how this will impact their work. But so far what I've seen is that there's been a lot of information about the context highlighting particularly the confounding variables. So our wearable designer said about the first workshop, the one where we talked about moving around the home, is that sort of the way that we were going through it now, through the workshop, we can sort of track where people are and begin to link the motor movement, and that will be really helpful for this project as well as beyond. So being able to understand that where people are in the context of their home impacts how that data from the wearable, from the EMU sensor, can actually be read and understood. Then if we think about more risk management, as we've talked more about the project and breaking down the project in this way, it's allowed people on the team to think more about the mitigation that needs to happen. So one thing that a data fusion person was saying, well, we actually need to have a better plan about what data we're going to be recording. And the integration engineer also was like, well, yeah, we're going to have basically a wearable and video. The video will only be saving, essentially we're only planning to save the skeletal points, but and those two modalities together can work to validate each other. But if the system is on the fritz or malfunctioning or whatever, then that's not good enough to have just those two sort of digital inputs. So it might mean that we need to have a diary level or a manual input to validate, or potentially they'd want to keep also the full frame video along with the skeletal points. Now, it's also been really useful because we're not only having the engineers talk about data, but also bringing in the end users, and specifically the people with Parkinson's who will be living with this system. And so they are able to talk about the practicalities of the system being in their home. And one thing that we've been talking about is to think about having a calibration or validation of the system, particularly in these early stages, to allow us to have a baseline of what sort of movements should be looking for and like how it's changing. So one person with Parkinson's mentioned that if I have to do this validation at the same time every day, that might not work because something could go wrong at that time, or something could happen where you get a phone call and you miss it. So being able to just sort of say, okay, now works for me, I'm gonna do the validation right now, today. So having sort of those other ways of validating and work with people's lives can be really helpful. And again, so one of our biggest things is that we are planning to put cameras in people's homes. And although they're only planning to do sort of the skeletal points, as our other person with Parkinson's mentioned, he was actually describing someone else who was on the project who was not comfortable with the cameras at all. He wanted to be able to turn them off, particularly when his grandkids or his wife were in the room. And even after being explained that the data would be only saved as skeleton points, he was not convinced. And one thing that we noted is that, this person was early on in their stages of Parkinson's, so they didn't have fall issues. While as those who have fall issues are more willing and open to having more of their data taken. So there is a lot of variance in participants and people whose data you will be gathering, because some people are more comfortable because they see the greater impacts of having all of their data gathered, whilst other people don't. So as I've said, this is preliminary work, and I'm still hoping to see how this will impact the development of the system, but that's pretty much it for me.